Last week, we went into acidity and again linked to acid-base equilibrium. Okay, so this one I want to talk a little bit here. Remember, there are three so-called compounds that we've been discussing in terms of acidity since alcohol topic, right? In the hydroxy compounds topic. Over there, we have alcohols, we have phenols, all right? And then we compare the carboxylic acid right now. We say that carboxylic acid is more acidic than your phenol, and phenol is more acidic than alcohol. Now, all in all, how do you talk about acidity of organic compounds? It has always to do with the ions and not the molecules. We always talk about its conjugate base, the anions, all right? So carboxylic acid will form your carboxylate ion like this, which will allow them to delocalize their electrons, as you can see, to form this version, which can reverse back. So we always have version A and version B. Shows that we don't know which is the one, and therefore we say it looks like this, i.e., the electron density or the negative charge is not on this oxygen and it's not on this oxygen, is somewhere around here. Okay, so it's delocalized, it's dispersed, it's not on the particular oxygen atom. All right, it is called dispersed along that space. And because of that, it makes it very stable. When it's very stable, it will not want to take back the H plus that it has given out. All right, I wouldn't say it's not, but less tendency to take back. And therefore, we say carboxylic acids are more acidic than your phenol as well as your alcohols. Now, if you look at phenol, it's a similar reason that we've discussed. Take a look at phenol. So let me use a different color. Phenol, say, be using so many colors here. Phenol, we don't talk about phenol when it comes to acidity. We talk about the phenoxide ion. So you still remember? Okay, this is a phenoxide ion. So it's all about the lone pair electron. Where is it? So if you look at it, there is delocalization also. All right, remember this? This can move into here, and this will move around, and then move back again. Yes, correct. So there is delocalization that can occur. So again, phenoxide ion is what? Is pretty stable. So again, most of you are here. You have to hold your content. Cannot today, I study very good, I do a test exercise, not bad. Next month, I ask you, you forget everything. Okay, you can't. Okay, so phenoxide ion is also resonance stabilized. Just like your what? So they have like a carboxylate ion. So it's quite acidic as compared to alcohol. So I'm very interested to compare two things right now. Which two? These two. Why carboxylic acid is more acidic than your phenol, all right? So here we go. It's about this versus this. Okay, so let's find some space. I'm going to write this down. Question, why carboxylic acid is more acidic? They're both weak acid, but still can compare, right? Than your phenol. That's the question. So, first of all, my angle is this. Both, all right, the carboxylate ion, all right, remember acidity, we don't talk about the molecule, we talk about the ion, all right? Both carboxylate ion and the phenoxide ion undergoes resonance stabilization. So by right, it should be, in a way, equally stable, right? So the question is, how come one is more stable than the other? That's basically our answer, all right? So, which is my answer right at the top in pink, okay? Both of them undergo resonance stabilization. However, the one, we can make a guess, this one more stable, everyone okay? Makes sense, right? More stable, therefore more acidic, but why, all right? So I'm going to write a word there. Okay, so the negative charge in the carboxylate ion is where I showed you is dispersed around here. Can you see? So this is a technical keyword. Is dispersed over 2 oxygen atoms. Whereas in your phenoxide ion, which is this one, right? It is distributed over only 1 oxygen atom. Understand? So it's still very near to the oxygen there. Are you with me? And so the lone pair is very available, in a way very available, very negative charge. You like to take back H plus. Want to take back H plus means you don't dissociate out that much. Lower acidity. Right. So in case anyone asks you why carboxylic acid are more acidic than phenol, this is the answer. Which will clearly so-called explain this phenomenon by now. Therefore, if they ask you to explain their order of reactivity, not a reactivity, okay, that is another mistake that I always make, and I want you all to be careful, right? So ready on this part? So this is the page, right, that we discussed before. So it's not acidity, reactivity, but acidity. Be careful, huh? Acidity, we don't say it's reactivity, because you write reactivity, we're gonna mark you wrong. Please take note. So now we are very clear that what? That carboxylic acid is more acidic than phenol and more acidic than aliphatic alcohol. First of all, we say what? First of all, we say both of these are more acidic because it has resonance stabilized structure. Everyone okay? All this we discussed, I'm summarizing further. Resonance stabilized ion, all right? The anion. Whereas this one, there's the alkoxide ion are not stabilized. Everyone okay? All right. So the RO minus is not resonance stabilized. And you should know what's the effect. So I managed to compare and bring alcohols out into acidity. After which, then we discuss, and therefore the answer that I gave you, these two. Everyone okay? Why carboxylic acids are more acidic than phenol? Because this carboxylate ion is more stable than the phenoxide ion. Why? I've given you the answer earlier on. Okay, make sense? Very structured. Okay, so all three so-called compounds, we are able to explain them right now. So this section on them is on resonance. I want you all to be careful and don't mix them together. This versus inductive effect are two different concepts, which a lot of y'all anyhow like to mix them together. Everyone, are you with me? In organic chem, there's a couple of concepts. These are the three, which you have seen them coming out in your tutorial answers from your tutors itself. Organic chem got these three concepts and they are not the same. Everyone okay? They are totally different concepts. So please choose your keywords carefully. All right? Resonance is about the electron can so-called jump from one double bond to adjacent single bond, right? So on and so forth, using the lone pair. Inductive effect is different. Inductive effect is electron donating and withdrawing effect of what? Of substituents. Please take note. And steric hindrance is another one, which later we'll take a look. Right? There are three very important concepts which are not the same. Everyone okay? So for example, very easy, and a carboxylic acid, it has resonance. No matter what, it always has resonance. But because of the substituent in a substituted carboxylic acid, it will have different inductive effect. Are you with me, everyone? But the resonance effect is always the same, because it's called resonance in the carboxylic ion. Everyone okay? Be careful, huh? These three keywords, they are not the same. Don't anyhow use. Okay, write a note. These three things are totally different. Know when to use them. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you'd like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.